We now know how to use an equation to predict the moles of product formed from the moles of reactant present. However, normally we weigh out reactants, so can we use the mole ratio with masses to predict the mass of product? The short answer is not quite. The reason for this is that 1 gram of iron doesn't contain the same number of atoms as 1 gram of oxygen, because each atom is different. So comparing masses doesn't give us a true idea of how many atoms are present. To do this, we have to convert our masses into moles, and this will be the basis of our calculation. The steps for doing these calculations are the same every time. If you can get into the habit of following the pattern, you can't make a mistake. First of all, we need to write a balanced equation, making sure we've got all the atoms on the left-hand side the same as the atoms on the right-hand side. The second thing we need to do, and this is really important, is to write down what you know. Generally, if you write it down underneath the equation, you can see exactly what it is that you know, and you can see exactly what it is you want to find out. The third step is to calculate the number of moles of the substance that we know. We do this using our formula of mass divided by molar mass. The next step is to set up our mole ratio from the substance that we know to the substance that we want to find out. Once we've done that, we can use the mole ratio to calculate the number of moles of our desired product, and then we can convert those moles back into mass again using our formula of mass is equal to number of moles multiplied by molar mass. This slide actually shows you the same information that we've just been going through, but it's done in a diagrammatic form, so it's a little bit easier perhaps to understand. We start first of all with the mass of what we actually know, our given substance of reactant. Then we divide it by the molar mass, and that gives us out the number of moles of our given substance. Then, if we multiply it by our mole ratio, we get our moles of our unknown substance, and then to turn those moles into a mass again, we just multiply it by the molar mass again. Alright, so let's see this in action. If we have 6.5 grams of aluminium reacting with excess oxygen, how many grams of aluminium oxide are formed? You remember the first step in our process was that we had to have an equation. And to do that, we need to identify which one of these substances are our reactants and which ones are our products. First up, we can start with a yield sign. Then we need to know that our reactants are going to go on the left-hand side of the equation. And in this case, we're going to have aluminium and we're going to have oxygen as our reactants. Then we need to identify our products. Our products in this case are the aluminium oxide. Make sure you get the formula correct for that you have Al2O3. Then we need to balance the coefficients of our equation. So we need to have 4 aluminiums, 3 oxygens, and that will give us 2 aluminium oxides. Alright, there's our balanced equation from the problem that we have. The second step in the process was to write down what we know and to write it directly underneath the equation. So we know we've got 6.5 grams of aluminium, that's our known substance, and our unknown substance is going to be how many grams of aluminium oxide we're actually going to form. So the third step in the process is to calculate moles. So we need our moles of aluminium. We do that by dividing the mass by the molar mass, and 6.5 divided by the 27, which gives us 0.24 moles of aluminium. Right, now we've got our moles of aluminium, and we need to work out how many moles of aluminium oxide we're going to produce. Alright, 0.24 moles of aluminium. Next step in the process is the mole ratio. We know from our equation that 4 moles of aluminium gives us 2 moles of aluminium oxide. So therefore 1 mole of aluminium will give us 2 divided by 4 moles of aluminium oxide. And we know that we've got 0.24 moles. So the moles of product that are going to be produced will just be 0.24 will give us 0.24 times 2 divided by 4. The next step in the process is to convert that moles of product into a mass. And the mass of the product is therefore just going to be given by 0.12, which is our number of moles of product, multiplied by its molar mass, which is 102. Make sure that you put the mass with the actual quantity next to it, so it reads mass of aluminium oxide, so you don't just have M's or N's or all over the place. You need to actually specify what you're trying to calculate. Once we've done this calculation, we come up with the answer of 12.24 grams of aluminium oxide. Here's another example. This time we're going to burn some butane in oxygen to make carbon dioxide and water. And we want to find out how much oxygen is going to be needed to make that reaction actually occur. First of all, we need to have our equation. Nicely complicated, but easily balanced when you spend a little bit of time on it. Then our second step was to write down what we know. First of all, we know we've got 150 grams of butane, and what we're trying to find out is how much oxygen will actually react with it. Third step, you remember, was to work out how many moles we have. So the moles of our known substance, which is our butane, is calculated by dividing the mass by the molar mass. Our mass here is 150, and our molar mass is worked out by taking 4 times the mass of the carbon plus 10 times the mass of the hydrogen. And when we work out that calculation, we get 2.59 moles of butane. So 2.59 moles of butane, how many moles of oxygen will that need? So to do that, we need our mole ratio. So 2 moles of butane requires 13 moles of oxygen. So therefore 1 mole is going to require 13 divided by 2. But we know that we've got 2.59 moles, so 2.59 moles will just give us 2.59 multiplied by our mole ratio of 13 divided by 2. So now we know how many moles of oxygen we're actually going to need. It comes to about 16.8. Now we need to turn our moles back into a mass again. So to do that, we multiply our number of moles of oxygen by its molar mass. 2 oxygens in a molecule, so 2 times 16, and that gives us our answer of 5.37.6 grams. So just to summarise again, we're really going to go from mass to moles to mass. And to do that, we need to take mass to moles by dividing by the molar mass, moles to moles by multiplying by the mole ratio, and then moles back to mass again by multiplying by the molar mass.